Methane gas drives superstorms on Uranus and Neptune. Scientists have discovered that the cause of the superstorms on Uranus and Neptune is methane gas. Uranus and Neptune, the outermost planets in the solar system, are referred to as ice giants due to their water-rich composition. Scientists know relatively little about these distant planets. However, after the Voyager 2 spacecraft flew by them in the 1980s, researchers observed that both planets occasionally experience massive, short-lived storms. These intense but fleeting storms occur only once every few years and are so large that they can be seen from Earth through telescopes. Researchers have long wondered why storms on these planets are so unpredictable. A team of astronomers has found that methane may be the key to controlling these storms. The findings were published on the gas.Uranus database on September 3rd. Storms form when heat rises from a planet's interior to its surface, where the hot gases begin to cool down, creating turbulence and triggering storm formation. However, while the interior of these planets is warm, their outer atmosphere is cold. So why don't storms occur all the time? The study reveals that methane is the third most common molecule, after hydrogen and helium, in the deep atmospheres of both planets. Typically, methane gas doesn't play a significant role other than drifting through the atmosphere, but the researchers used a 3D cloud-resolving model to simulate convection. According to their simulations, the typical velocity of dry convection in the deep atmosphere is quite low, about 1 meter per second, but it's sufficient to transport methane upwards, while moist convection at the methane condensation level is heavily suppressed. Methane generally exists as a gas, but in the upper regions of these icy worlds' atmospheres, it can condense, forming droplets that fall to lower altitudes, the researchers suggest. There, the methane warms up and rises again, completing a cycle similar to Earth's water cycle. When the atmosphere becomes oversaturated with methane, a stable layer forms. Like a wet blanket, this stable layer prevents heat from reaching the surface, thus stopping storms from forming. These layers are commonly found across all latitudes on Neptune and around the equator and mid-latitudes of Uranus. However, Uranus's poles don't have enough methane to form a stable, saturated layer, allowing heat to easily rise to the surface and produce larger storms, the study explains. On the other hand, Neptune has more methane, and researchers found that occasionally methane can break through the stable layer and spread throughout the atmosphere. This allows heat to circulate, enabling storms to form before the atmosphere stabilizes once again. On ice giant planets, weak dry convection and strongly suppressed moist convection are the norms. However, when enough methane is transported upwards via dry convection and turbulent diffusion, rare moist convective storms can form. These storms are expected to occur more frequently on Neptune than on Uranus, due to Neptune's higher internal heat flow, the researchers concluded. The study's authors suggest that further research is needed to fully understand how different factors in the atmospheres of these ice giants interact with one another.